Hello there, and welcome to Lesson 4 on this series on musical electronics for Arduino, created for the students at Saturday Academy. My name is Will Patillo. I'm the instructor for this course, and in today's lesson we're going to be moving from playing a single note on the press of a button to playing an entire song. So to start with, I'm going to comment out these two functions. Actually, I suppose I could leave the light switch in place, but comment out button tone. And instead, since I want to play a song when the button's pressed, first I'm going to just take this if statement and put that right into my loop. And then here, I'll just delegate the song to a new method called playSong. And then I'll declare that down here, void playSong. Alright, now playing a song is essentially playing multiple notes. And when you need to do something multiple times, then you'll typically in programming use some kind of loop for it. And when the loop is of a known length, that commonly means a for loop. So what that looks like is this. For, open parentheses, int I equals 0, I less than note count, I++, and then open and close braces. I is just a common convention for index used to iterate through a loop, and we're declaring it right here with this int I, so it's only going to exist for the duration of this for loop. And it starts out as 0, and then first we check whether I is less than note count, and that is a variable we haven't declared yet, so I'll just take care of that right now so I don't forget. Right up at the top, int note count equals, let's say, 3. We can always change this later. First when we first enter the for loop, we set I to 0. Then we check whether I is less than note count. So yes, 0 is less than 3. And if that's the case, then we execute the code inside of here. Everything that's in these lines. And then once we're done, once we reach the end of the segment, then we increase I, and then check the condition again. So now because of this, I is 1, that's still less than 3, so we execute the for loop again. Once we get to the bottom, go back to this I++, I is now 2, 2 is less than 3, execute it again. Then we come back here, I++, I is now 3, 3 is not less than 3, so then we exit the for loop and go down here and continue on with our code. So that's how this is going to work. So to keep this simple, I'm just going to play the same note multiple times, and since we already have something for playing a note, that's down here, this tone speaker, note D3, I'm just going to copy that and put this right here. Now if I just leave it like this, it's just going to continuously play this note and never stop. And that's because this line sets the speaker, or this pin 10, to play a tone until you tell it to stop. And right now nothing's telling it to stop. We're exiting the for loop, but we're not actually turning off the sound. So to end the sound, we need this no tone line. Like this. However, this isn't going to really work that great either. It'll just turn the sound on and off, on and off, on and off really quick for a total of 3 times, because Arduino is just going to execute through these lines as fast as it can. We want these notes to last some amount of time, so for that we need a delay. And if you stuck through the blinking light episode, then a lot of this stuff of delays is going to look a little bit familiar. So I'll say a quarter of a second, 250. So play the tone, wait a quarter of a second, turn off the tone, and then wait another quarter of a second, and that should be good. So now I will verify, make sure there's no compiler errors, and upload this. Now when I press the button once, it plays the note 3 times. And if I change this note count, say to 5, and upload this, it's now going to play that same note 5 times. Just like that. Okay, so that's fine. We've gone from a single note to however many notes we want. But that's a little boring because we're playing the same note every single time. And, changing this isn't going to help because it's still going to be the same note each time. So what we want is to have this be like some kind of variable, or to not have it hard-coded in this play song method exactly what note we're playing, just to be able to change it as we go. And for that, I'm going to use an array. Create a type of variable that contains multiple of the same type of variable, and then we can put different notes inside the array, and then as we iterate through this loop, we'll also iterate through the array and play the notes that are inside of it. So if that didn't make any sense, don't worry, we'll just see what that means as we write it out. So right here, actually I'll just put it here, I'll say int, and I'll call this chime, and then open and close brackets because this is an array. And then I'm going to just fill the array right here by putting these open and close curly braces, and inside there I can start putting in some actual notes. So I'll just go into all caps. I'll say note C5, comma, note G4, comma, let's use this one again, and let's try an A4 maybe. So this is an A in the 4th octave, and let's that G4. I kind of like the sound of that. Let's use that again. And then we're kind of on a roll with these 4s, so but let's mix it up and make it a B4. And then finally, let's take something. We started with a C5. Let's end with a C5. Okay, so there. Yeah, that's a series of notes. So this is 1, 2, 3, 4, 5, 6, 7. Okay, let's make our note count 7. So now we have an array that has 7 notes in it. The first element of the array is C5, then G4, then G4, then A4, then G4, then B4, then C5. And next we're going to go back to our loop and iterate through these. So if I go down here where it says note D3, instead of that, I will say, get out of caps lock, chime, and then brackets I. So right here, how this is going to work is the first time when int I is 0, when we get down here to play this tone, we will play the 0th element of the chime array, which is this note C5. When we iterate through the for loop the second time, then I is going to be 1, so then this will be a 1 right here, and we'll play element 1 of the chime array, which is note G4, and so on all the way through this. Now, one thing you want to be careful with in arrays is when you're accessing them, you don't say try to access element 8 in an array that only has 7 notes in it, because then you'll get an index out of range error, which will cause problems. But fortunately, we're avoiding that with this note count variable, because we just have to make sure that this number matches the number of notes in this array. And as long as that's the case, then we should be fine. So let's see what happens now. And there is an error. And that is because I forgot a semicolon at the end of this array right here. Okay, and no errors now. And now I'll upload this and see what happens. Alright, so we have a song. but it sounds a little weird right now. Part of that is just because the notes are short and the delays are kind of long. So instead of using this 250, 250, I could experiment around with some values like 750 and 100. But actually, you know what? I don't like this because like guessing and checking on it. I think what would be better is to just have a variable right here for note duration, and then here in this second delay thing, I'll just say note duration divided by 3. Something like that. So that way there'll be a logical connection between the pause between notes and the notes themselves. And if I change this note duration, like if I like the relationship, then if I change the note duration, I don't need to change this delay. So let's try this. And oh yes, note duration has not been declared. So I need that up here. So let's say int note duration, and this is going to be in milliseconds. So let's just go with that 250 again. Okay, and I press the button. Alright, that's sounding a little bit more natural. But one thing I'm finding is a bit of a limitation with this is that all of the notes are the same note duration. And that's that's a little bit limiting. I want to be able to specify as I go through this array that maybe some notes are half time or some are quarter time, and half notes, whole notes, make it a little bit more musical. So one way I could make this a little bit more variable is to have another array that kind of aligns with this one and stores an array of these numbers in it. So I'll call that int and time signature, and make this an array, equals, open and close curly braces, and I'll say something like 250, 125, 125, 250, 250. Keep a couple more of these 250s. Let's see, 1, 2, 3, 4, 5, 6. And now since I'm using this time signature array, I don't need this note duration variable anymore. So now I can go into my song, and instead of note duration, I'm going to use time signature, and that will, oh yes, time signature I, and then for the delay, I can just use this same thing divided by 3. Okay, now let's save, and alright, I forgot my semicolon again. And upload this. Let's see what it sounds like now. Okay, not bad. But there's one thing that still doesn't quite sound right, and that is, just another limitation that we're seeing with this setup, is that it's always playing a note. I mean, I could change what note it's playing, but there's never any. But songs often have little gaps in them, pauses, and so I'd like to have some way of just using a note as like a rest. And I mean, I suppose I could find some tricky way of adding an extra delay in here, but I think what would be better is to just treat a rest like a note so that it fits the timing really well. Just say right here is if the value inside of chime is some special number, something that would not exist anywhere in this header file, such as 0. Then, instead of playing a sound, I just play nothing. And if the chime is any other value, then I play the note. And whether or not I play the note, I'm still going to delay by the whatever's in the time signature, and then have a no tone again, whether there was a tone or not. There definitely won't be at this point. And then have a delay with this same amount once again. I can just throw in right here in this little last section right here. We'll just test it out by just throwing in a 0 right between the G4 and that. And then I'll just make it the same length as most of these other notes, just throw in another 250 in there. And also, now that my arrays are both 8 long now, I changed the 7 to an 8. And right, so yeah, using that 0 so that I can skip a note once I get here, and it'll be that same length as those other ones. Click upload and see what it sounds like now. Alright, so that is a nice simple little song that I have going. If you change these notes, you'll change the melody. You can put zeros wherever you want. If you want to add a rest in there somewhere, you can change your time signatures if you want to speed it up or slow it down. You can play pretty much any song you want in here, and you just have to make sure that the length of this array matches this one, and that this number right here matches the length of both of these arrays. One other little thing I'd like to clean up, though, before wrapping up this lesson is I'm finding these kind of numbers are a little awkward to work with, or at least they are if you have any kind of music background. You want to, like, musicians are aware of whole notes and half notes and quarter notes and eighth notes. Like 125 and 250 doesn't really mean much. So instead, I'd like to just use that notation and then convert to milliseconds in code, just to make the programming a better interface. So I'll say that, yeah, this is a quarter note, this is an eighth note, this is an eighth note, quarter note, quarter note, quarter note, quarter note, quarter note. Then, down here, when I get into this for loop, I can say that, let's create a little temporary variable, int note duration, that variable's back now, equals time signature I, 1,000 divided by this time signature. So that's 1,000 divided by the time signature. So if we have a quarter note, that will be that 250 that we had before. And if we have an eighth note, it'll be 1,000 divided by 8. So the bigger of a number we have in the time signature, the shorter it gets. And if we wanted to, we could use something else instead of this 1,000. So anyway, we got this. Right here we've converted between these nice, conveniently musical notation and actual time in milliseconds. And now we can just use this note duration instead of time signature I. So yeah, right here, swap that out, just like that. And this should work exactly the same way. But be a little bit easier for a musician to read. But that is all for this lesson. Thank you very much for watching, and I will see you in the next one.